Ladies and gentlemen, good evening. Tonight we're going to talk about ArrayList versus LinkedList versus a vector. So when should we use the ArrayList? When should we use the LinkedList? That's what this episode is going to be about. First of all, let us just see how an ArrayList actually functions and works, because there's actually an array behind the ArrayList. And if we just create an ArrayList without any arguments, then there will be an initial size of 10. So the initial array behind will have the length of 10. And what happens is that every time we insert an element, then that element will be inserted into the next index in the array. And then when we have too many elements then in an array, then the array will be increased. The size will be increased by 50% at a time. So initial size 10, it does not allow primitives. They will be, if you try to insert a primitive integer, then it will be casted into the integer instead of the int. So it allows null values. It allows ArrayList. It allows duplicates, so we can insert the same object or the same value twice or multiple times. And usually, sometimes it's referred to as a dynamic array or resizable array, or as an array that can grow in size. It is very, very bad for insertion and removal. It performs very, very bad, and I'll show you in just a minute why this is the case. It is very good for retrieval, because an array, when we ask for the object at a certain index, then it is very, very fast. It will be just as fast to take array element number 10,004 than it would be as taking element number 4. So it's very, very good for retrieval, and this is not the case for the linked list. The linked list is that is opposite with the linked list. The linked list is very slow for retrieval, because the linked list, it has the reference to the previous value and to the next value inside each element, and it's not an array list just as we have with the it's not an array as we have with the array list. But let me try to show this in a draw schema right here. So this is LibreOffice Draw. This is my initial array. I have 10 slots right here. 3, 4, 5, 6, 7, 8, 9. There's only 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10. So then we have an array with 10 slots, and then we start on adding. So then we execute the method add and something, and then we can add if we're not using generics, because ArrayList actually support generics. But if you don't give a generic, then it's a type object that we can add to the ArrayList. That means that we can add anything. So that means that then we can add an integer as the first slot, and we can add a string in the second slot, and then we can add maybe a double in the third slot, and maybe we can add a boolean in the fourth slot, etc. And then we can just add stuff. I'm just going to use numbers. It's a little bit faster to type for the last of the slots. Then we add 7, then we add 4 again, then we add null, just because we can. Then we add 4 again, just because it is possible to use duplicates, right? And then we add 3. And now I try to add the number 10. What will happen now is that we will actually get a copy. A copy will create it, and actually a new ArrayList will be created, and all the values will be copied into this ArrayList right here. And then the new ArrayList will not just be 10. Will just not be 10 slots. It will be 15 slots instead, because it will grow with 50% every time. So we just make sure that there's enough space. Then I'll take the last element here, copy it, paste it, and then I'll just delete the value right now, because we need to add 5 more slots right here. That is how the ArrayList works. So there's 1, 2, 3, 4, 5, like this. So now we have 4 more slots, and then now I can add the number 10 that I want to add. At the same time, this array will be eligible for garbage collection. That means that this will be deleted. I'll just delete it. It will be garbage collected as soon as a garbage collector comes, and thinks now is a good time to collect the garbage from memory. So that means that the memory cleanup will happen automatically. So now I added the number 10. Okay, so this is when we add stuff. When will this array shrink that is behind the array list? It will never shrink. That is a short answer, because that's just how it's designed. So So actually, we can actually take up some memory. Let's say that first we had like 10 million 10 million elements in our array list, and then we shrink it to so there's only 3 elements left. Then we will actually take up the space. So there could actually be so up to the 3 million in the array list. So of course, we need to know that so that maybe if we wanted to shrink, then maybe we could create a new array list and then help that way to clean up or free up some memory. But let us just see what happens if I want to add an element. Let's say I say add element at position 4. Oh, okay, let's say at position 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I add an element at position 9, what will happen is a shift operation. So that means that all the elements would shift one position. That means 10 will move to this slot right here. 3 will then move to this position right here, and 4 will then move to this position right here, and then my new value will be inserted right here. Maybe that could be 9, right? So that's called shift operation. So, and try to imagine if we have thousands of elements in an array list, or in the array that we have right here, then of course that will take a very long time. It's not performing that good, and that's why array lists in general are not good for insertion, and they're not good for removal either, because when we remove one, let's say I want to remove this null value right here, the way that works is that this will be deleted, and then we'll have a left shift operation. That means that this will shift one slot to the left. The same with this element right here. The same with this element right here. So then we shift all of them left one slot. And this is also it's not very efficient. So if we're having a lot of these operations, then we will spend some CPU time on doing this. But let us try to look at how the linked list works. The linked list is actually made up of a lot of objects, a lot of objects that have the reference to a value. So it contains a value. So maybe we have the value. It could be 15 right here, and then it has a reference to the previous value right here. Let's try to give it another color. Let's just give this another color. And yeah, so now we got this color right there. And I'm going to paste it right there. So that means, and if this is the first element, then I would just be null right here. There's no reference right here. And then the next reference will then be the next element. Let me create a new element. So that means that if I create a new element right here, if I insert a new value to my linked list, that could be maybe 10. Then the previous value right here, that would then be 15, because then I pointed to the 15 right there. And that means that then the next value right here, that will then be 10, because we'll have a reference to this object right here. And of course, it's referenced by it's a reference. It's not the value itself that is present in each element. That's important to understand. And then we can create one more. Copy paste right here. This is the linked list. Then the previous value right here, that is a reference to 10. So this element right here, 10. And then maybe the value right here, that could be 20. And right now we don't have any more elements, so this will be null. So there's no reference, there's no end reference right there, because we only have 3 elements right now in our linked list. And the next will then be the reference to 20 right here, right? This makes it, of course, very difficult when we need, if we want to fetch a value, then it's very difficult, because then we need to jump through each of these elements one by one to find maybe, if we want to find the number 20, then we jump, and then we find the number 20 there. We cannot just say, give me the third element. If you say, give me the third element, we still need to jump through all of the elements one by one. So it's very slow for retrieval, but for insertion, it is really, really efficient, because then I can just say that I want an element after this 10. That is very efficient, because then I just do like this. Maybe I want copy paste. It did not work. Let me just try again. copy, paste. Yeah, now it works. So now if I want to create a new element, I want to put in a new element in right here. Instead of doing a lot of shift operations and shift all the elements one to the right, then what I do instead is that then I just, let's say that I wanted to add the number 30 right here. Then I'll just change this reference. Instead of this pointing to this element right here, then this would just point to this element right here. So that means that it will just point to 30, and the previous value here, then that would be 10. The next value right here will still be, would then be 20. The previous value also need to be changed on this one to point to the new 30 element. So let me just do that, 30 like this. And I know I'm typing in the values, but you just see there's a reference to the object. It's not the value itself. So that means that when we need to insert a new element in the linked list, then we just need to manipulate and modify 2 elements. So 2 elements, that is not much compared to maybe 10,000 elements if that's how many we have in the ArrayList. So if you want to do a lot of insertion and removal, of course the same with removal, then I would just take one out and then I'll make these point together to each other again. So if you have a lot of insertion and removal, then use the linked list. There's no doubt about that. If you have a lot of retrieval where you want to get want to extract the information, then use the ArrayList. So what about the vector? When should we use the vector? The short answer is almost never, because the vector, it is a thread-safe version of the ArrayList. It has been there much longer than the ArrayList. I think it was it has been there much longer. I think it was from Java 1 or something like that. And then the ArrayList came in Array 1.2. I'm not sure about these numbers, but that's what I remember. It is thread safe, so it's synchronized. Of course, it's good if you need a list that is thread safe, then use the vector. But you would almost never need that. So I would say never use the vector. You need to have a really good idea. So it's a very slow version of the ArrayList. Another thing is that it grows with 100% of the length. That means that it takes up more memory than the ArrayList does. Don't use the vector. It's in a lot of textbooks. I've never really understood why, but don't use the vector. Queue and stack is something you might also have heard about. Queue, that is more like something you create to solve a problem. It has nothing to do with containing data in my perspective. A queue uses the first in, first out principle. That means that it only gives access to the first object that you placed in. So then you continue adding objects, add objects, but it's still the first element that you have access to, and then you can pop this first element at some point. So it's like push and pop, pushing and popping elements in the queue. The same with the stack. That's just all the way around. It's last in, first out. So that means that every time you add an element, then that would be the element that you would have a reference to. So stacks are queues, and they're used for specific problems. But I hope this gave you some information on ArrayLists versus linked lists. If you need to insert or delete elements, then use the linked list. If you need to do a lot of retrieval, if you want to take out a lot of values, elements, or read them, then use the ArrayList. And remember again, do not use the vector. Thank you very much for listening. That's all what I have for tonight. I hope to see you again soon. Have a great evening. Bye-bye.